All right, folks, this is a non-right triangle. Okay, non-right triangle. So what do we know about it? It does not have a right angle. It does have three sides. You know that? Like, okay. You know, when I say non-right, the only thing you know that it's not right angle, or it does not have right angle. So if I were to ask you, if I already put in like some missing side lengths up there, or angle measurements, or whatever, and ask you to find a missing side length or a missing angle measurement, could you use SOHCAHTOA? Well, if you say yes, then defend your position. Why could you? Well, I don't. So, but what if I put some in there? All right. So, give me a degree. 36 degrees. Give me. So, okay. And then let's say at this side here it's X and this is 20. Can you use SOHCAHTOA? You can? It has to be a right triangle to use SOHCAHTOA. Okay. So sine is defined as the opposite side divided by hypotenuse. What kind of triangles have hypotenuses or hypotenusi? Right triangle. So SOHCAHTOA does not work here. So how could I find, in that question, how could I find X? That's what we're going to investigate today. So, every single triangle has three altitudes. And an altitude, anybody remember what an altitude is? Okay, how high it goes. How would you explain that from this picture here? Let me put some letters in here. Let's call this A. Let's call that B. And let's call this C. Describe where or what you would call the altitude. How would you gain that? Dax, what were you going to say? If this was a right angle, A to B would be an altitude. Okay, so you're saying go from B and drop straight down so that it is what to AC? Perpendicular. Okay. We know that line should exist. Every triangle has three altitudes. That is simply just one of them, right? Okay. Because angle B is probably obtuse up there, the other two altitudes would be on the outside of the triangle, but they would still work. Okay. This process here that we're going to go through would still be validated regardless of whether the triangle is acute or obtuse. Okay, so what did that just create? Two triangles, but they're now both right triangles, correct? So let's call this distance, just for the sake of staying consistent with our area formulas, let's call this distance H. Okay. Let's say that when we talk about triangles a lot of times, this is a trigonometric concept. I think we may have seen it once or twice so far this year. If I want to talk about the side that is opposite, so I'm looking at the entire triangle, the blue triangle. If I want to talk about the side that's opposite angle A, generally we call it lowercase a. If I want to talk about the side that's opposite angle C, we call it lowercase c. And opposite angle B, we call lowercase b. Okay. Now lowercase b is that whole side there. Okay. Now let's look in triangle. I'm just calling this triangle number 1. Look in triangle number 1. And can we look at angle A, look at H, and look at C? What would H be in regards to angle A? Opposite. What would C be? It'd be the hypotenuse. Okay? Because we're looking at triangle 1, which is just this blue triangle, right? Okay? So we're looking at just that blue triangle. Would you be able to say that the sine, you said opposite and hypotenuse, that the sine of A is equal to H over C? Is that fair to say? Okay. Let's look at triangle number 2. And for the sake of this part, let's look at angle C. Look at angle C. What would H be for angle C? Still opposite, right? What's A going to be? Hypotenuse. So let's say the sine of C is equal to opposite, which is H, over hypotenuse, which was A. Okay. Let's go ahead and solve both. Let's solve this red one for H. What would I need to multiply both sides by to get H by itself here? C. So you get C times sine of A would equal H, right? Let's go over to this one on the right-hand side. What would you need to multiply both sides by there to get H by itself? Multiply by A. Okay. What do you know about the H in both those equations? Why do you know they're the same? Yeah, it was that distance right there in both triangles, right? So it's a common side. So can I say this? If C sine of A is equal to H, and sine A of C is equal to H, okay, so I can say C sine A is equal to A sine of C. Is that okay with everybody? Okay. Now, what that does, that's actually what we call our law of sines. We're going to go a little bit further with it and make it easier for us to remember. But what this actually does, when we use this in a problem, it automatically takes our problem that is a non-right triangle. It automatically finds that H distance, that altitude's length in there for us without actually presenting it to us. Does that make sense? So it realizes it's there, it uses it, and will ultimately then spit out the information that we're interested in. Okay? But to make this easier, can I divide both sides of an equation by anything that I want to? Yeah. Okay. So I'm going to divide both sides. And it can be found, you can do this in 2 steps or 1 step. I'm going to do it in 1 step. You can divide both sides by A, and then divide both sides by C. So why not just do it all at once, divide both sides by A times C? Does that kind of make sense? Okay? Because I can do division however I want, right? As long as I do it to both sides. What's going to cancel out over here on the left-hand side? That C and that C, right? And on the left-hand side, it's going to leave you sine of angle A over side A. On the right-hand side, what's going to cancel out? The A's, right? And it's going to leave you sine of C over C. And that structure might be a little bit easier to remember our law of sines. Okay? I'm going to go one step further. You guys don't need to write this down. But there is another altitude that we could look at. I'm going to try to clean this up the best I can. There might, now the way I drew this, the altitude probably be on the outside. I'm going to draw it like it's right here. So let's say that's H. Okay? If I looked at angle B, because that's the angle that hasn't been discussed down here, right? I could say that the sine of B would equal H over A. H over A. And then I could say the sine of A would be H over B. Oh. Doing the same exact thing that we did down here, we could take this one here and say H is equal to A sine of B. And we take this one and say H is equal to B sine of A. Does that make sense? And then we get A sine of B is equal to B sine of A. Divide both sides by AB. A's cancel, leaves me sine of B over B. Here the B's cancel, leaves me sine of A over A. Okay, so here's my question. If that's true, and if that's true, is there a common component in both those? Is there a ratio that is identical in both those boxes? Sine A over A, right? Sine A over A is the same. So here we're saying sine of A over A is equal to sine of C over C, and here we're saying sine of A over A is equal to sine of B over B. So that's a transitive property, which allows us to make the connection that sine of A over A is equal to sine of B over B, but is also equal to sine of C over C. Okay? And that is called our law of sines, which is going to allow us to find the length or angle measurement of a triangle if it's a non-right triangle. Okay? And there's three ordering of parts that they can give us that would allow us to use this. Okay? It's angle, side, angle, 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 side, and side, side angle. And I'm going to put some asterisks on that one, because that one is a pain in the read that word backwards. Okay? Because that problem is, when we get one like that, it's probably 2 to 3 times longer than the other problems. Okay? That's how I remember that one. And then I've got extra steps to do. So we might get to, it's called the ambiguous case. We might get to that. It just depends on our time. And I'm not too worried about us addressing it for the end of course exam. But the other two techniques, the other two orientations of side lengths and angles might be important for that test. Okay, so what's this do for us? How do we go about this? So the one thing I want to make sure we understand is that when we look at our original triangle, okay, looking at that phrasing right there, capital A, lowercase a, they're opposite each other. Capital B, lowercase b, they're opposite each other. Capital C, lowercase c, they're opposite each other. So what we're going to do is we're going to take our picture, if it's a non-right triangle, and we're going to fill in capital A, lowercase a, capital B, lowercase b, capital C, lowercase c. Okay? Some of those things are going to be variable, some of those things are going to be numerical. We should always, if the law of sines works, get 2 of those 3 ratios to be able to set up a proportion that has 1 variable in it. Okay? And then we should be able to solve for that variable. So, if you're a person that printed off the notes, that's what a lot of this initial information here in the notes is talking about. Okay? Scroll down to here. Okay, and what I'm actually going to wipe away a bunch of this and just kind of walk through the technique that I think is the most appropriate for being able to do this. Now, obviously, as you guys do these, just like anything, I don't, and you've had math classes that are this way that the teacher says you got to do it the way I do it. I don't ever believe in that. Okay, I think maybe the way I show you might be the initially your best approach, but if something else, another technique or procedure makes more sense to you, or you can shorten the procedure a little bit, by all means, go ahead and do it. But I think this is the best approach as we move forward. They're going to take this figure here, and they're going to ask you, can you solve the triangle? Can you find everything else? Okay? So right now we got 3 parts. When they say solve the triangle, they mean find all 6 parts. So right now, do you know measure of angle C? You can find it. So I'm going to subtract 93 and 48 from it, right? And it gives me 39 degrees. Okay. This side here would be lowercase c. This side here would be lowercase a, right? Now, because we don't have a right triangle here, we could not use SOHCAHTOA. All right, that's how I know I need to turn to the law of sines. So I'm going to say, I'm going to write my law of sines, sine of A over A equals sine of B over B equals sine of C over C. And I'm going to start filling in the things that I know. Do I know capital A? Do I know lowercase a? So it stays A, right? It stays lowercase a. I don't know that much. Do I know capital B? Do I know lowercase b? Lowercase b would be the side opposite b, right? So in this case, it would be the 15. Do I know this angle C's measurement? 39. And I don't know lowercase c, right? So I go in and I fill in all the things that I know. Now that's called an extended proportion, correct? And in an extended proportion, I'm going to number these. 1, 2, and 3. I could use ratios 1 and 2 together, and they would be true. I could use ratios 1 and 3 together, and they would be true. And I could use ratios 2 and 3 together, and they would be true. Does that make sense? As a proportion. Now, if I use 1 and 3 together, does that leave me 2 variables, A and C, in an equation? If I have 2 variables in an equation, that's a problem, correct? Okay. But if I use 1 and 2 together, how many variables am I left with? I'm left with 1 variable, A, in that case. So let's put these 2 together and say now the sine of 48 over A is equal to sine of 93 over 15. Okay. Now, remember, this is what we've been working on all since 7-1, I think. This is a proportion. How do you solve proportions algebraically? Cross multiply. So when I cross multiply, I'll multiply those 2 things. And remember, sine of 93 is just a number. It's a value for some other number. It's pretty close to 1. Okay? Like 0.9 something. So it'd be A times that number equals, now I cross multiply here, 15 times sine of 48. Okay? Now I think it's imperative to draw comparisons to our algebra just so you know kind of what we're talking about here. So I'm going to do this in Desmos real quick so you can see. We have right now A times sine of 93 equals 15 times sine of 48. Okay, that's what we have written down as our problem. But sine of 93 is actually that number right there. Make sure I'm in degrees, okay? So if you remember, I did say it's pretty close to 1, so 0.99, go up that far. So really I have A times that equals 15 times sine of 48, right? Does that make sense? Now generally, if this is my coefficient, we would probably put A behind it, right? So my hope is that you see that side right there is exactly the same as that side right there. And what is common is that they both have the A. So that must mean that 0.9986 is the same thing as sine of 93, right? What would you divide both sides here by to get A by itself? 0.9986, right? So what would you divide both sides up here by to get A by itself? Sine of 93, which is the same thing as that 0.998. Does that make sense to everybody? Okay. So here, divide by sine 93. Those will cancel and cancel. Come over here, divide by sine 93. So you get A equals 15 sine of 48 over sine of 93. And that's the exact value of what A's length is, which if I gave you that value and I said, go up on the number line and put it on the number line, absolutely nobody, including myself, is going to know where that goes. Okay? So we're going to take our calculator and see what it tells us. Now, order of operations, if we understand order of operations, this would be okay. Okay? But a lot of times people are going to prefer to see the 15 up in the numerator like that. But you see that it still gives me the same result regardless. Okay? So 11.16. 11.16. Make sure you're in the right mode. Make sure degrees is highlighted. 11.16 is that distance for A. Is that all right with everybody? Okay. Now here's my question. If I come back up here to my extended proportion, now that I know that A value is 11.16, can I use ratio 1 and ratio 3 to find C? Because that would leave me with one variable, right? Can I use ratio 2 along with ratio 3 to find distance C? Because that as well would leave me with one variable, right? Which choice would be better? If I write these out, sine, so we could write sine of 48 over 11.16 equals sine of 39 over C, or sine of 93 over 15 equals sine of 39 over C. Take 1 paired with 3 or 2 paired with 3. Which one of those is better? The second one. Why the second one? Okay. That number right there, in comparison to that number right there, one of those is rounded and the other one is not. 11.16 was a rounded value from a previous calculation, right? So if I use that, it's okay for probably for all the things that we do, it would be okay. All right. I would make sure that I don't want to round it to like 11.2. Like if Math Excel says round to the nearest tenth for C, I would want to make sure if I use 11.16 that I don't round that to a tenth, because then the product, when I cross multiply and then the division, is going to compound that error, and it might mess up the tenth place, okay, of my final value for C. So if I can avoid that at all costs, I will. So I'll use this because that's going to be a much more precise answer. usually like in, of course, exam stuff, they will do like, I don't know how to phrase it, but it'll be written in a manner in which it will be okay if you use that value. Just because of the rounding that they tell. They'll say, okay, you just found this to be 11.16. Now use that value and round your final answer to like the whole number or something like that. Okay, so that error is taken care of. On an ACT, because this is a common question on the ACT, obviously it'll be a multiple choice. So if you go through this using either one of those, if you use this one, this will probably be like one of your choices, A, B, C, D. But if you use this one, you're going to have an answer that's really close to A, B, C, or D, right? And then you can be able to choose that one that's real close. So I cross multiply here, I get 15. Sine of 39 equals C sine of 93. So now how do I solve for C? What would I divide both sides by here to solve for C? Sine of 93. Cancel, cancel. Sine of 93. So there's my value for C. Type that in. I get 9.45. Okay, which if we would have used, so that's the exact value. So let's just real quick, if I go 11.16 sine of 39 divided by sine of 48. So this top one's the best answer. This one is using a rounded value. You see they start differing in the thousandths place, right? Okay. Just be aware of that. Is that okay? Is that something we can do? So that's what they provide me with here. They provided me with an angle. So going off of the initial conditions, they gave you an angle, and then a side that was not between those two angles. So they started you with that orientation, angle, angle, side. Okay. So that's why we use the law of sines. I'm going to skip this one. Like I said, that's the one that's a pain in the butt. Maybe do that tomorrow. This one here is what do they say? What's the order of parts that they're giving us here? Angle, side, angle. Okay. So I want you guys to take a minute. Let's just call this, this would be lowercase b, this would be lowercase c, and this would be lowercase a. I want you guys to set up your extended proportion. You don't need to go ahead and solve anything yet, but just set up the three ratios that you would use with the law of sines. Huh. How big was angle B? 90. Okay. So traditionally, you would not use law of sines here. It works. It'll be okay. But if that's a right triangle, I probably should have realized this before I gave you this one. You got a better option, don't you? Isn't SOHCAHTOA a better option? Okay, but let's use law of sines and see what happens. If I go sine of 90 over 27, right, is equal to sine of 39 over A, which is equal to sine of 51 over C, correct? Okay. Now, which one, if I say ratio 1, ratio 2, ratio 3, basically you can't use 2 and 3 together right away, right? Because that's two variables. So 1 with 2 or 1 with 3 is what you're going to have to go with. So I'm just going to go with 1 and 2. So if I go with 1 and 2, I get sine of 90 over 27 is equal to sine of 39 over A, right? Cross multiply, correct? Cross multiply, I get A sine of 90 is equal to 27 sine of 39. And now what would you divide both sides by to get A? Sine of 90, right? So 27 sine of 39 all over sine of 90. Okay. I'm gonna grab my. I'm gonna do the other one as well right away because I don't care. To be honest, and hopefully it's to the approach that you take as well. I don't care what that value is as a specific value right now, as a rounded decimal, because I'm not going to use it to find C, right? So I'm just going to go ahead and do sine of 90 over 27 equals sine of 51 over C. And I'm just going to go run through that one as well. So it'd be C sine of 90 equals 27 sine 51. And then C will end up being 27 sine 51 over sine of 90. Is it okay with everybody? And we can just plug those into our calculator. So when we do that, so 27 sine of 39 over sine of 90. Give me that right there. Okay, so that's what this A value is. If I want to find C, which was 27 sine 51, gives me that, right? Okay, just real quick, let's just see real quick. If I go A, call this B, if I go A squared plus B squared, is that the Pythagorean theorem? Anybody know what 27 squared ends up being? So I just found A. So this was the, let's see here. So that side and that side were these two values, 16.9 and 20.9. Square them, add them together, gives me 729. What's 27 squared? 729 again, right? So this was a right triangle, so that should match up with the Pythagorean theorem. I'm just trying to show you previous information we've learned, how we can use that to validate what we're doing. Here's my next question, though. How can I get to, if this is a right angle, let's find A a little bit easier. Let's go with this angle right here. Okay, what would A be in comparison to that 39? Opposite. And what would 27 be? Hypotenuse. So sine of 39 would be A over 27, right? What would I multiply both sides by? 27? 2. So then I would get 27 sine of 39 over A. If we know that that's okay, and let's just double check. If I go (27) sine of 39, does that give me the same 16.99 number up here? Okay, so here's my question. that there in comparison to that there. Let's get rid of this one here. What is the only difference between those two expressions? Divided by sine of 90, right? Well, what is the only number that you're able to divide something by and not change its quantity? 1. So what do you think sine of 90 is? Sine of 90 is exactly 1. Okay? So that is why the law of sines works here, but it is also why if they give you a right triangle, don't go, you see all the work here for sine using law of sines? I mean, it'll work, but it'll be maybe twice as long as using traditional SOHCAHTOA. Okay? We would find the same thing here. If I look at 51, find C, this would be opposite of our hypotenuse, so a little bit easier to find C using SOHCAHTOA. Does that make sense? All right. All right, let's do this one. Find AB. This one is not a right triangle, so we'll just take the time, just find the one segment. We don't have to find both of them here. Both unknowns. All right, so how big is the angle A? 16? All right, so we have to use, and a lot of times, and this is what I was saying earlier, is like if you don't find it necessary to write all three proportions, and you can figure out which two, or I say all three ratios, and you find out which two are going to lead you to your answer right away, then don't feel the need to write the third one, okay? A fail-safe thing to do is to write all three of them. So sine of 16 over 9, sine of 63 over C. So if I'm a person that says I can realize which two I need right off the bat, and I'm going to write those two, then just write those two, okay? If they're only asking for C, okay? But I'd also know that sine of 101, call this lowercase b, should look like that, right? So then I can just pick out the two that are of interest to me that are going to produce the distance that I'm interested in. Okay, so those are the two that's going to produce C. So I'll say sine 16 over 9 equals sine 63 over C. Cross multiply, right? My hope is that you see once you have the proportion constructed, the algebra is identical every single time. Cross multiply, then find the variable side and divide by the sine of whatever is on that variable side. So sine 16 and then we've got our C value. Is that okay? Did you guys come up with that, which is as a decimal, because they're going to ask you, so that's the exact value. Obviously, they're always going to ask you, what are these rounded to whatever decimal. So 9 sine 63 divided by sine 16, 29.09. Is this okay? You got questions on this? So what if I can't, what do you think would happen? Let's say that I had, so we said that side-side angle is an option, okay, which is, we'll start with this one tomorrow. Side-side angle is an option for us that we would use law of sines, but it's a pain in the butt because what could happen is that basically when they give me angle-side angle or angle, side. What that means is, think about this. If I were to give you guys all 2 side lengths and 1 angle measurement cut out of cardboard, okay? And the side lengths that I gave you were cut out of like yarn. And everybody had the same 2 side length measurements, and everybody had the same angle. And I said, every one of you order them as go the side, and then put the angle in the middle, and then put another side. No, let me rephrase this. We need angle, side, angle. So I give you 2 angles cut out of cardboard. 2 angles cut out of cardboard, and 1 string. Okay? Give you all the same measurements. And I said, everybody take your 2 piece of cardboard, 2 angles, okay, and put them angle, and then the side, and then an angle. Okay? So put the side in between the 2 angles. Every one of you is going to get the exact same triangle. It is because of congruency. We had an angle, side, angle congruency, right? It guarantees that those triangles made will always be the same. Okay? If I tell you to put them in the order of angle, angle, side, again, it's going to guarantee congruence. So everybody's going to get this exact same triangle. Okay? If I gave you, this is where I was getting backwards at the beginning. If I gave you 2 sides and an angle made out of cardboard, and I said put them in the order either side, side, angle, or angle, side, side, okay? Some of you, and I give everyone the same dimensions, there will be situations where some of us might get no triangles, okay? And that would be the case if one person got no triangles out of that configuration, then everybody's going to get no triangles out of that configuration, okay? But there might be, depending on how big our sides and angles are in comparison to one another, if I told you to put them in angle, side, side order, some of you might get 1 triangle that is acute, and the others are going to get 1 triangle that is obtuse. But there's still going to be 2 true triangles. Does that make sense? Because angle, side, side is not a congruency theorem or postulate, so it does not guarantee congruence. When I take those parts and put them in order, it does not guarantee congruence. Okay? It could happen, but it doesn't guarantee it. So, in that situation, there might actually, when I give you angle, side, side, there might be 0 triangles that can be made from that information. There might be 1 triangle that can be made from that information, and there might be 2 triangles that can be made from that information. So that's what we call the ambiguous case, because we don't know at the onset that there's going to be 1 solution like we do with angle, side, angle, or angle, angle, side. Okay, so that will be what we discuss tomorrow. Like I said, it's a pain because of the extra steps that we have to go through. I'm going to try to show you the physics of what I just walked you through that might help you realize why we go through some of the steps we do and deciphering the number of triangles and what the answers are. But it's very structural. It's very to be successful in an angle side side question, you got to be organized with your work. Okay. So those are those components. But what do you think? Like if I give you side side side, if I give you side side side. So let's do this. Let's say I gave you like 10, 15, and I don't know, 13. If I gave you those sides, okay, so let's call this A, let's call this B, let's call this C. I'd say sine of A over 15 equals sine of B over 13 equals sine of C over 10. Now my variables are the angles now, but no matter which 2 of these I use, will I always have 2 variables? And that would lead me to no conclusion. I can't use law of sines to solve this problem. Does that make sense to everybody? For the same reason, if I gave you something like this, let's say I gave you, let's say this is 60 or 75, let's say this is 65, let's say this is 60, and I ask you to find x. If I say sine of 60 over x equals sine of b over 75 equals then sine of c over 65. No matter which 2 I choose there, if I choose those 2, I got b and x as variables. If I choose these 2, I got b and c as variables. If I choose the first and last, I got C and X as variables. So the law of sines doesn't work there. Okay? If I think about these orders, these parts, this is side, 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 an ordering of parts, and this is side, angle, side. If the law of sines does not work there, what law do you think might work there later on? Not SOHCAHTOA, they're not right triangles. So SOHCAHTOA only works in right triangles. But we have a law of sines today. What do you think we're going to have in 2 or 3 days? A law of cosines. Okay? So that's the next topic after we get through tomorrow's stuff that we'll learn the law of cosines. Okay? This stuff, so here's one of the things that happens as you guys get older and you go through other courses. A lot of you will end up taking physics. Okay? And when you get to physics, there's a lot of math in physics in which that math is prerequisite, meaning he doesn't teach the math. He doesn't teach you how to do the geometry when you're inside physics because you've already graduated geometry class, right? Okay. You will use law of sines, law of cosines in a physics class. Okay. When you start talking about vectors and motion and that kind of thing, forces. So what I want you to make sure we understand is even if this stuff doesn't show up on the end of course exam, the end of course exam is really not the end all be all for what we cover in classes. Because my goal is for you to then take what you learn here and be successful in a science class. Take what you learn here and be successful in one of my trig classes or college algebra classes or whatever. Okay. This stuff will not go away. So law of sines, law of cosines, this stuff that sticks around in multiple courses. We just finished talking about it actually in my trig class. Okay. We only spent a day on it, but they just had their test over chapter 5 in that class, and part of it was law of sines, law of cosines. Okay, but we obviously dig into it a little bit deeper, and that sort of thing. When you get to physics, you'll do a lab with vectors, and he asks you to find a vector is a line segment with a direction and length. Okay, he'll ask you to find the length of a line segment and the angle of direction, but never tells you how to do it, and you have to use the law of cosines to do it. That's the geometry that should pop up. So just kind of give you, I think it's obviously a lot of things make more sense, or maybe we invest in them more now if we know that they're going to pop up in the future.